Hello everyone, it's time to solve using the quadratic formula. Now, I know we are champions at factoring, so let's just go ahead. You give me a quadratic, I'll solve it by factoring all day, no big deal. I'm going to find numbers that multiply to negative 24 and add to positive 4. 3 times 8 is 24. It's positive times a negative, so it's negative. And I'll make a table and I'll be like, I can do this. I can find numbers that multiply to negative 24 and add to 4. Like 1 and 24, those multiply. 2 and 12, 3 and 8, 4 and 6. 6 and 4 is a repeat, so must be up there somewhere. Which ones are 4 apart? How can I put a minus sign? That would be plus or minus 23. That would be plus or minus 10. That would be plus or minus 5. That would be plus or minus 2. Not everything's factorable, folks. So I might say solve by factoring. I mean, I probably wouldn't say that if it's not possible, but you need to realize, hey, that's not possible. You can't solve this problem by factoring. I did, I put in the directions, but you can't. And the reason why is there are no numbers that do this. So we can't continue. We can't proceed this way. We have to have a different strategy. If it's not factorable, you can't use factoring. But good thing for us, we have the quadratic formula. So the quadratic formula is the x solutions are negative b plus or minus the square root of b squared minus 4ac, big fraction bar, all over 2a. And you might want to write yourself a couple notes. First of all, this is ax squared plus bx plus c. That's standard form of a quadratic. So when I say a is the coefficient for the x squared term. B is the coefficient for the x to the first term, and c is the constant term that doesn't have an x. That's what those a, b, and c are about. The other thing is the part underneath the radical, b squared minus 4ac, we have a name for it. It's called the discriminant. Discriminant. There we go. Okay. And it's on the next slide. We're going to talk about that a lot today. That's a big deal. Okay. We always start by finding that first, and that kind of tells you what's going to happen. If you find the discriminant first, you're going to be like, oh, I remember this. Okay. That's going to tell you what you should expect to see. And it's very useful to do. It makes the process a lot easier as well. So here's the formula. Learn it, love it, memorize it, be good at it. You should remember it from Algebra 1. But let's do a couple problems now. Let's actually solve this problem using the quadratic formula. So I'll write it again. The more times you write it down, the easier it is to remember. B squared minus 4ac all over 2a. All right, so if you want to, especially at the beginning, you want to label A, B, and C. It's not a bad idea. A is 3, B is 4, and C is negative 8. If it helps you to do this, then do it. Okay? AX squared plus BX plus C. A is 3, B is 4, C is negative 8. Okay. Let's actually do our substitution for the discriminant first. I always find this first. So B squared minus 4AC. B squared is 4 squared minus 4 times 3 is A, and C is negative 8. And you type this straight in your calculator, so I'm going to use my calculator now. Where's my calculator? Okay. B squared, 4 squared minus 4 times, I'm just using parentheses to substitute, negative 8. B squared minus 4AC is 112. 112. So the discriminant is 112. That's this part. And I'm going to come back to the radical stuff for today. We're just going to leave it as 112. But here's what you're going to do. Plug it in. The opposite of B, the opposite of 4 is negative 4. Plus or minus the square root of 112 over 2a, 2 times 3. Now be careful. Negative 4 plus or minus 112 over 6. Okay. When I actually write my answer now, the last thing I want to do, we'll come back to these radicals like I said, is I want to divide everything by 6. So I'm going to write this as negative 4 over 6 plus or minus the square root of 112 over 6, which equals negative 2/3 plus or minus the square root of 1. I want your answer to look like that. And that's actually 2 answers. Okay, there's 2 numbers here. Negative 2/3 plus the square root of 112 over 6. Is that supposed to be a 2? I think it's a 2. Or negative 2/3 plus or minus this, or I gotta stop talking while I'm writing. This is minus. Plus or minus. There's 2 answers. This and that are my answers. And you can get the decimals, but I don't want decimals anymore. I want exact answers. This is the decimal. And the other one is negative 2/3 minus the square root of 112. over 6. So if you want the decimals, 1.097, negative 2.43. But I'm going to kind of run with this one a little bit. I'm going to show you some things that you might want, and that is the first thing. If I have this number, I can store this in my calculator, this STO key, store this as a letter, and I always pick the letter A. It's green, so you hit alpha first. I'm going to store that as the letter A. And what I'm going to do is go back up to the top and check my answer. So I'm going to plug it in. 3 times A squared plus 4 times A minus 8. Instead of x, I'm plugging in that whole decimal. The computer is just doing it for me. So 3 times negative 2.43 squared plus 4 times negative 2.43 minus 8. I should get 0. Oh, that's 0.00000000001. So that's a really, really small number. That means 0. That's scientific notation. That's 0. So we got 0. Okay? I checked my answer using the calculator. But I want your answers to look like this. They're going to be kind of gross, but it's Algebra 2. They're going to get worse. Let's try another one. Solve using the quadratic formula. Okay, it equals 0. Let's go ahead and write the quadratic formula again because, again, it's really good practice. B squared minus 4AC all over 2A. So, first, the discriminant, B squared minus 4AC. 2 squared minus 4 times 8 times negative 3. B squared minus 4 times AC. I'll type it in my calculator. 2 squared minus 4 times 8 times negative 3 is 100. Ooh, nice. This is gonna be a good one. 100. So now I fill the rest in. The opposite of B is negative 2 plus or minus the square root of 100 over 2A. I'll write that as 16. 2 times 8 is 16. Now this one, I can actually get nice friendly numbers because the square root of 100 is 10. So I will simplify that to be 10, and now I'm going to split it up. Negative 2 plus 10 and negative 2 minus 10. So 8 over 16 or negative 12 over 16. Those simplify to 1/2 or negative 3/4. Those are your solutions using the quadratic formula. And you can test them by substituting them back in and you should get 0. But I feel pretty good about that. So in the first one, we had a discriminant that was not a special number. 112 is not super useful or special, but 100 is a perfect square. And we got nice numbers. This was way better. Okay, I just want you to think about that. We're going to come back to this. Let's try another one. Get everything on one side. So first, subtract 4x on both sides. You need to set it equal to 0, so you need to subtract 4x on both sides. I'll write the formula again. B squared minus 4AC over 2A. All right. So discriminant, B squared, make sure you put that in parentheses. B squared is negative 4 squared minus 4 times A, which is 4, and C is 1. This 4 is just part of the equation. Okay, I can show you where it comes from, but it's just part of the equation. So there will always be a 4 there. This is going to be 0, I think. Negative 4 squared minus 4 times 4 times 1. And it is 0. Okay, so again, we get something interesting. 0. So I fill in the rest of it. The opposite of B, the opposite of negative 4, is 4 plus or minus the square root of 0 over 2 times 4. 2 times 4 is 8. Now, since the square root of 0 is 0, this is just like saying 4 plus 0, which is just 4 over 8. So the only answer to this one is 1/2. Okay, so we had 2 gross answers, we had 2 nice answers, and then we had 1 nice answer. Okay, let's see if we can maybe pick up something else in the practice. So I'll write the formula at the top. B squared minus 4AC over 2. Now, I'm a math teacher who's done this for a long time. I still write it this many times. If you have written it less than me, I want you to consider you're probably not going to remember it as well. So write it down. It's good practice. Keep doing it. I know the formula. You should keep writing it down. Let's go through the discriminant. B squared minus 4AC. All right, so I'll just type it in my calculator. Negative 8 squared minus 4 times A times C. 24. Okay, 24 is not a perfect square. All right. And this one I need to first get everything on one side, add 15 before I do anything. Because a, b, and c have to be in standard form for this to work. So when I do the discriminant here, b squared, 4 squared minus 4a, it's positive 15. You have to move it to the other side so you get that right. 4 squared minus 4 times 2 times 15. Negative 104. Okay. All right. So let's keep going on this one. I've got the discriminant. The opposite of b would be 8 plus or minus radical 24 over 2 times 10 is 20. And we're just going to write that as 8 over 20. Those are both multiples of 4. So 2 over 5 plus or minus radical 24 over 20. Okay, I can reduce 8 over 20, but this is just 1 over 20, so I'll just leave it as 1 radical 24 over 20. When I do this one, I'm not going to get very far. The opposite of b, the opposite of 4 is negative 4. Negative 4 plus or minus the square root of negative 104 over 2 times 2, which is 4. Now, when you see this, at least for now, you should be like, hey, square root of negative 100, square root of negative anything. Can't do that. That's not real. That's a complex number. We're going to come back to the complex stuff, but for now, we're just going to say there are no real solutions. And that R has an extra line. It looks like it's a double R, like double line there. That's because it's a symbol. Okay, that means the real number set. And we'll talk more about that when we get to complex solutions. But for now, we're just going to say there are no real solutions. So last thing I want to do is sort of summarize what we have seen. If the discriminant is positive, so here, that was a positive 24. This was a positive 100. This was a positive 112. There are going to be two answers. That's just one answer. This one had two answers, plus and minus. So the first thing is there will be two real solutions. Two real, I'm using that symbol again, solutions. This means real numbers. Talk more about those sets later. If the discriminant is negative, like this one, you're going to square root a negative, and you're going to get no real solutions. We'll talk about imaginary solutions later. But right now, no real solutions. If the discriminant is 0, we had one like that. Here the discriminant was 0, but we only got one number. We just got positive 1/2. So there will be one real solution. And the last one doesn't tell you how many solutions you're going to get, but if the discriminant is a perfect square, like in this problem, we didn't actually have to use the quadratic formula for this one. We could have factored it. This one, it will tell you if it is factorable. And the reason that I like that is when we go back to the first problem, you might spin your wheels and be like, why can't I figure this out? It's not factorable. I couldn't find the numbers at the beginning. But the way you really say it's not factorable is you say, look, the discriminant is not a perfect square. 112 is not a perfect square. So I know for sure it's not factorable. And that's sort of the way that when you get to really complicated factoring problems, it's nice to know, you know what, I can keep looking, but I'm not going to find numbers that multiply to this and add to this. So if the discriminant is a perfect square, it can be factored. If it's not, it is not factorable, or we might say the word prime. That's all I got for now. Like and subscribe.